Okay, so if you're listening to this session on negative indices, I'd like you to just have a look up the front. That's why. So year nines, because I'm teaching now, I'm going to ask you to be quiet if you're still working. So up the back, quiet please. All right. I'm blocking. Okay, so I'll just teach like this so you can see. Okay. All right. So if you've forgotten everything, remember the big idea with indices is repeated multiplication. Okay. So if I have 7 to the 3, that just means having the number 7 3 times, and I'm multiplying them all together. What's happening as I go up? If I go up the list, how does my number change? I'm multiplying by what number? Okay, so if I've got one row and I want to go up, just multiply by 7. The reason why I'm saying this is because you might wonder what happens if I keep going below 1. So last week we defined 7 to the power of 0. Can you see that if I want to get to 7 from some number by multiplying by 7, the only number that's going to work is the number 1. Because 1 times 7 is 7. I can't use any other number here. I have to use 1 for this pattern here with the 7s to continue. Okay. Now we're entering pretty challenging territory as far as year 9 math is concerned. We're now going to define what it means to take 7 to the negative 1 and 7 to the negative 2. You can probably guess where this is going. I want the pattern to continue. So if I'm going up, I want to be able to multiply by 7 to get the next number. So let's start with just 7 to the negative 1. I don't know what this is yet. I'm going to define it now. But I need to choose a number so that if I multiply it by 7, the answer is going to be 1. The question is, what goes inside this box? So I'll give you a few moments to think about it. I need a number which, if I multiply it by 7, will give me an answer of 1. And whatever number I choose here, this is going to be my definition for 7 to the power of minus 1. So put your hands up, guys, if you think you know what number should go in this box here. Some number times 7 gives me 1. All right, Sam, what do you think? All right, Sam has proposed 0. 0, there's a problem with 0. What happens if I multiply by 0? You get 0. So, not 0. Okay, so Mitchell has proposed 1. So, just note that 1's already been taken here by 7 to the 0. 1 times 7 is going to give me 7. But I want my answer to be 1, right? I need to choose a number, multiply it by 7, and get the answer 1. Okay, McKenna. Minus 7. Very interesting suggestions here. Yeah, because 7 times 7 is 49. And so if I put a negative sign in front of one of the numbers, I'll get negative 49. So it's not 0, it's not 1, it's not -7. Think back to your algebra days here. 7x equals 1. What's the solution to this equation?
X, we have to just presume 1.
To what?
We just have to presume that x is 1. Like we just have to guess it's 1. Isn't it?
But 7 times 1 doesn't give me 1 though.
Nah, but like, I don't know. Just use.
Okay, Louis? X equals 1/7.
Or x, that 7 to the power of -1 is 1/7.
Yes. Okay. Let me start a new page. If I have 2 halves, does that make a whole?
Yes.
Okay? So you believe me, but if I wrote this equation down the bottom, does that look familiar or unfamiliar to you? This is okay? Alright? What should go with the 3 to make 1? A third. What should go with the 5? 1/5. What should go with the 7? 1/7. Okay? So this is where we are going today. We're going to define 7 to the -1 equals 1/7. We're going to define 5 to the -1 equals 1/5. 3 to the -1, 1/3. 2 to the -1, 1/2. Why? Because we get that pattern happening. So we're going to define 7 to the -1 as 1/7. Can you give me thumbs up, middle, or down at this point, please? Okay. All right. All right. I'm going to throw caution to the wind here. And I'm just going to... Huh? What? Oh, it's a figure of speech. All right. So sometimes in maths, I teach you a rule. Sometimes I'll explain to you where the rule comes from. What we just did, I was trying to explain where the rule came from. And the advantage of doing this is that you have a better understanding, but it also takes longer. And it can be more confusing. And because quite a few of you have this or this, I'm just going to give you the rule now. Okay? So have a look up here, see if you can spot the pattern. So these are all fractions.
Would you not just write 1/49?
Yep, you could. Can anyone see the pattern yet?
Yeah.
What's the pattern? Yep. So if you've got a negative index, I like that. Move it down to the bottom in a fraction. Okay? So this is going to be...
Is it always if you got a negative?
Yes. So...
What is it like a positive?
Well, if you've got a positive, you just do what we've always done, right? Okay, so I think your book calls this index law number 4. If I have A, so here I used 7, there's something special about the number 7. If I raise a number to the power of minus n, it's the same as dividing by a to the n. Okay? Once you know that, you're pretty much good to go. So I'll just give you a second to get that down if you haven't gotten it already. Alright, so there's a few more things you need to know. So you got that. Alright. What about this one? What happens if I divide by a fraction? Does anyone know what happens when I do that? So imagine I have the number 3/5 and I divide by it. Do you know what I get?
Do you get 3 over 5? 3 to the power of 5?
You flip the fraction upside down. Okay? So imagine a situation where I divide by 1 over a to the n. Now I need to flip this upside down. So I have a to the n divided by 1. That will just leave me with a to the n. Okay, and the last one is the reciprocal. This means flip the fraction upside down. So for example, the reciprocal, am I blocking the screen? Kind of. Reciprocal of 3/5 is 5 over 3. Alright, so once you know this, you're pretty much ready to go with 2D. But you need to know 2C before you can do 2D. So if you're still working on 2C, feel free to keep going. I think what I'll do is I will run the quiz tomorrow morning in our class. Okay, so give you some time to master 2C.
Is it first period?
Yeah, we're not. Yeah,
If it's first period,
we've
we're not
got the
here.
investiture symbol.
We don't know.
Everyone gets their patches.
We don't need
Should we do
to.
the quiz instead of starting?
Wait, what? Is it still 12?
What is it? 9 to 12.
What?
9 to 12?
Yeah.
What?
Everyone gets their patches for everything.